Hey guys, this is our review of the assignment for week of May 25th. This is the start of our review on fractions, decimals, and percents. All right, so the first page is just kind of getting us in the math mood. The first question is a magic square. It says numbers in each row, column, and diagonal have the same sum, which is called magic sum. This is really close to a Sudoku. So basically a sum, I put it up above here, it's the result from addition. Addition, subtraction, multiplication, and division, the answer has a different name. In addition, it's called a sum. So when you see sum, it always means do an addition question. So for this, we're going to look at, we only have one full line. So we're going to look at what does 9.3 plus 6 plus 2.7. If I add those all up together, I get a total of 18, I think. I just did some mental math. So 9.3 and 2.7, I put those together. So that gives me 12 plus 6 is 18. And so then I start looking this way, 3.6 and 6. And then what number am I missing in order to get 18? Remember that we're using decimals. Once I have those two, then I'll be able to get this one, and so on and so forth. I'm not going to go over the riddle one because it's just looking at different math words to solve a riddle. Again, we're just getting in a math mood so that we're ready to start going. Okay, the first one is about mental math. It's a review, so it's asking you to use mental math and it's showing you what the solution looks like. So if I was doing 36 times 4, I might break that into, well, what's 30 times 4? What's 120? What's 6 times 4? That's 24. Okay, 144. And it's going over different ways to use that mental math. So it's asking you on the bottom, if you were to use mental math here, and it was 289 plus 171, how could I make that easier? So for instance, it's telling you that you're going to take 170, which means that that one is all going to be by itself. So it's going to say, it's saying that to add 289 plus 1, that's a lot easier than doing 289 plus 171. And then after we have that, we have 290 plus 170, and then that's taking it into a much easier math question that we can do in our heads. We might have to think about it a little bit. But then it's asking you to use your mental math strategies and explain. This is more about what is your mental math strategies, not so much what is a right mental math strategy. All right. It says percent means per 100 or out of 100. One whole or one is 100%. So it's saying 25% is 25 out of 100. 4% is 4 out of 100. 100% is 100 out of 100. And so you guys kind of know that, right? Like if you get 100% on a quiz and it was 100 questions, you know that you got 100 questions, right? Now it's saying what percent of the grid is shaded. Oh, goodness. And this one I should have looked at more to make sure that it photocopied right, because right here it's supposed to be 27% of these. So what I'm going to do, because I'm just doing this for the first time in real time with you guys, what I'm going to do is I'm going to put out a notice for this for the bottom of page 49. What you are going to do is do your own. So you get to shade in however much you want. And then you're going to tell me what is the fraction. So what did you shade in over 100? So say I shade in, I'm going to do 32, right? I did 3 rows of 10 and 2. So I'm going to say that that is 32 over 100 because that's my fraction. And that is 32%. But you can do however much you want. And then tell me what the fraction, what the percent is. So fractions to decimals. In order to switch a fraction to a decimal, so it starts out with a quick review. 1/4 or 1 over 4 is read as 1/4 or 1/4. 1/4 means 1 divided by 4. So to write a fraction as a decimal, I change the fraction to an equivalent fraction with a denominator of 10, 100, or 1,000. Now that's where it gets a little bit more complicated. An equivalent fraction means it means the exact same thing. So I know already that 4 doesn't go into 10, so I'm not even going to try to do a fraction over 10. I want to try a fraction over 100. So when I'm doing this, I know you've done it before, you got to figure out, what do I do to 4 to get to 100? I know using my mental math that I times it by 25 to get to 100. I have that pretty set in my brain because of money, like 4/4 equals 100. And so then to create an equivalent fraction, I need to do the exact same thing on the top. So 1 times 25 is 25 over 100. Now it's telling us exactly that right here. Now if I want to change this to a decimal, I know it's going to end in the hundredths place, right? This is the tenths, and then the next one is the hundredths. And so 25 over 100 looks like 0 and 25 100ths. Or I can just divide it, right? 1 over 4 means 1 divided by 4. So 1 divided by 4. And it demonstrates the math there. So it says to look at this fraction, 25 over 99. This is a never-ending repeating decimal. And so it says 25 over 99 is 0 and 25 100ths. In order to put that as a repeating decimal, you just draw a bar over the repeating digits. So if I did this division question, it's 0.2525252525, and it'll never stop. As soon as I get that, I draw a bar over the repeating part. And in this case, it's both 2 and 5 that are repeating. If it was like 0.255555555, it would only be the 5 that would have the bar on top. It's whatever part repeats. So you can use this pattern to change some decimals to fraction form. So anything that's over a 9 would have a repeating decimal in the tenths. Anything that's over 99 would have a repeating decimal in the hundredths. All right, you can use this pattern to predict that the fraction for 0.2 repeating is 2 over 9. So it says identify each decimal as terminating or repeating. So a repeating decimal, again, is that one that repeats over and over again. And remember, how did we show that it was a repeating decimal? Well, it had a bar over top. So I can tell you right now that this one is a repeating one because it has a bar over top. Now, anything that doesn't have a bar is going to be a terminating. It says match each fraction with a corresponding decimal. So I'll do 1 for you. I know that 16 over 99 is going to have a repeating decimal in the hundredths. And so I know it's right there. What fractions form repeating or terminating decimals, and what fractions form repeating decimals? So you tell me, what's the difference between a terminating decimal and a repeating decimal? Hint, just go to the one before. We can see that terminating decimals end like we're able to put them over like 10 or 100 or 1,000. That's a hint. All right. And then the terminating decimals, what are they over? All right. It says complete this table. So it says fraction with a denominator of 10, 100, or 1,000, fraction in the simplest form, and a decimal. And it's giving you something in the table. So remember, I always say do the hardest one with the teacher. This one seems kind of hard. So 0 and 256 1,000ths. We know that it's going to be 256 over 1,000. And we know that we can make this simpler. Now remember, in order to simplify a fraction, we just need to divide it by the same thing on the top and the bottom. So basically, I want to look at this and say what in the world could I divide both 256 and 1,000 by? So if I don't know what my long-term answer is going to be right away, I start with things that I do know. So 256 over 1,000, I know for sure that these are both even numbers, so I know that I can divide it by 2 straight off the bat. So if I want to do that, let's see, dividing this by 2, it's 128 over 50. Well, right away as I know, well, probably could have gone smaller, because looking at this, I can see that I can still divide each of those by 2. So I can do that again. Remember, these are equivalent fractions, so they all equal each other. So if I divide 50 by 2, it gives me 25 on the bottom. And if I divide 128 by 2, that gives me 64. So, goodness, I've really messed up, because right in the beginning it was 256. It was supposed to be over 1,000. I put 100. That makes my answer much different. So I need to add a 0 on each of these. I was just realizing that when I got to the end, I had an improper fraction, and I didn't start out with an improper fraction. So remember, when you're doing math, you're always double checking those things. Another way to take this to equivalent fraction but quicker would be to use all those division rules that you used in the last assignment and look at what numbers go into here. So I can look right away to see if it's divisible by 3. The way that I do that is I add all the digits together, 2 plus 5 plus 6. So that's 13. It's not divisible by 3. So then I know I can divide that whole number by 3. But if I look at, is it divisible by 4? The rule for divisibility by 4 is that you look at the last 2 digits. So in this case, that's 56. And you say, is that number divisible by 4? And in this case, that number is divisible by 4. So I could have told right off the bat that I could divide both 256 and 1,000 by 4 and get my equivalent fraction. So that's a lot of math to get me one part in the table, but in the end I have it, which is 64 over 250. We're going to do the same sort of thing with everything on this table to find the simplest form of the fraction with a denominator of 10, 100, or 1,000, and the decimal. It says use a calculator to write each fraction as a decimal. I don't have a calculator here at the smartboard with me, so I'm going to trust that you can do it. The way that you do it is by treating this as a division question. So if I'm looking at this, I'm saying 2 divided by 9. I punch that into my calculator and I write it out. Now remember, 2 divided by 9, I know already that that's going to be a repeating decimal. So make sure that you draw that line over top when you draw your repeating decimal. All right, express the fraction as a decimal. We know that all of these are going to be repeating decimals because they all end with 99. So we'll do the first one together, 0.88. We know it's repeating. Describe the pattern in the decimal in part A. So it's saying, what is your repeating pattern? We can just actually even do 8 here. So once you have 8 over 99, 9 over 99, 10 over 99, 11 over 99, it's asking you to describe the pattern that you see here. I'm not going to do it because obviously you need to complete this in order to see the pattern. Use the pattern to predict the decimal forms of 5 over 99 and 21 over 99. So after you see exactly how this works with the pattern over 99, you'll be able to really easily predict what 5 over 99 is and what over 21 over 99 is. All right, we have a couple more pages, but this video is going to time out at 30 seconds, so I'm going to pause it now and do a part 2.